Everybody, it's Tyler here down at the Texas Cup. Checking out team number 8515. This is Photon. This is the development team for Spectrum. In their first year, building a brand new 2021 robot, and a really cool robot that they have here. So we're going to be talking about, of course, the whole power cell journey, the intake, coming into the tower, the shooter, all that and more coming up. And to help me out with that, I have Felipe, Janet, and Jared. And we're going to be checking out all this and more coming up on Behind the Bumpers.
Giving you a voice.
Making it loud our own way.
Welcome to the fun.
We would like to thank our friends at Stryker for supporting fun so we can continue to make content for you. Stryker makes some of the most revolutionary medical equipment and is a big supporter of FIRST and its participants. If you are looking for an internship or career that supports you being in FIRST, check out careers.stryker.com to learn more. If your team or organization is hosting an off-season event, did you know you can stream it right here on First Updates Now for free? Events that stream on First Updates Now receive an additional 25 to 100% additional viewership because we help you promote your event on a large platform. If you're interested, reach out to us on any of our social platforms, on Discord, or send us an email at admin@firstupdatesnow.com. Let's get your off-season event streaming on First Updates Now. Hurry, dates are booking fast, and we take first come, first serve for all our events.
So Jared, start us out on this robot here. We're going to be talking about the intake coming in. Looks like got a couple cool components to go into it. Tell me a little about the process of developing it and what makes it happen.
Well, basically our first idea was how to keep this stowed so we can start matches like this. So to do that, we had hooks, and basically the way it works is that they latch onto the sides of the intake, and then when we're ready, when the match starts, we just deploy it and it rolls out. But basically, the way this intake works is that we have 3 rollers, and they basically guide the balls up with this bar here, being able to catch the balls. And then on top of that, we also have additional wings on the side to make sure that we don't have any balls fly out while we're intaking balls. One other thing to note is that we have multiple other bars for support, and that we also have springs that make sure that they're really, really sturdy.
And can we see the the intake deploy? Just check that out. So that's where you see these wings really come into play, right? Yep. That they're able to keep that in. That makes a lot of sense of that. Talk to me a little about the material. So you said to make it sturdy. So I guess why not just go with a solid roller the whole way? What made you choose like this type of material for it?
So we really like the polycarbonate rollers because, well, A, they're really light, but also we prefer dead axle versus live axle.
Yeah.
So we 3D print all of our pulleys and end caps, and we have needle bearings inside of them that just ride on this shaft that you can see inside right here.
Makes
it
a lot
also
of sense.
goes really well with our aesthetic.
Yeah. So Felipe, why don't you continue us on here as we'll go into the indexer and the tower as well too. Tell us a little bit more what's going on there.
All right, sure. So from our intake, we move on into our indexer. It's just powered by one Falcon, and we just have a bunch of wheels just spinning to try to get it up and into our tower. We have several ramps across this little area here. So these ramps covering the swerve modules, as well as a downward sloping ramp to try to guide them more into the wheels and thus into the tower.
So as we go into the tower here, so we got a couple of those Omnis that go on. What is that? There's an additional wheel that's kind of over that black wheel that's next to the Omni wheels. What's the purpose of that serving?
This black one here?
Yeah.
So that's just like, we just have a 4-inch stealth wheel. We're just trying to ensure that we never get balls caught in that corner or in some other corner, just trying to prevent jams as much as possible.
Yeah, no, that makes sense. Take us into your tower mechanism then.
Okay, so our tower, we just have more polycarbonate rollers riding up all the way, and we're geared up to spin faster and faster as we proceed up towards the shooter. But on the bottom, we have hex shafts with 2-inch Omnis, just so that way the balls can slide in really easily before shooting up.
So as we continue up in the tower, we're going to go in the shooter here. Some interesting things. I'd love to hear about your choice of different materials that you're using and a little bit more into your flywheels as well.
Okay, so our 3D printers are our best friends this season. We purchased like roughly 12, and we've just been printing everything we have because it's just so much easier to build, and the PLA is pretty solid. It doesn't break. We haven't had many issues with PLA breaking. So like all these pulleys, instead of buying them with like the herringbone really expensive, we can just print our own, and it's just really simple and easy.
And you actually see, you guys are actually have been 3D printing some stuff in the background there too. So you're doing it right here during the competition, right?
Yeah.
So that's pretty cool. What are you actually 3D printing right now?
We're 3D printing a replacement gear for our indexer because we had some issues with it in the previous match.
Sure. So Janet's going to take us into the climber here, and then we're going to be talking a little bit about the bumpers and drive area as well too. So tell us a little bit more about your climber.
Okay, so our climber is pretty simple but really effective. Basically, we just wanted something that could lift our light robot up. What we have is just 1x1 tubes, chain, and if you look, we have this plastic covering just so that balls don't come in and mess with our stuff. But if you look inside, we have a gear and a sprocket, and it's just hold in place. And to lift the actual climber up, what we did was we nailed the chain onto the 1x1 tube on the bottom, and that way, whenever the chain goes around, it lifts this tube up, the top part, and it lifts the robot up. And to create tension, we have the tensioner right here, which we twist with a 7 wrench. And up here, we just have a gusset and bolts and rivets just to hold this together.
Sure.
These husks are made so that whenever we climb, and the two we just don't want it to go into places that it's going to mess up our climber. So these husks kind of like hit, and they travel up and land directly into our hooks so that we can climb consistently and hang onto the bar correctly.
So this is pretty much your max height area. Are you able to essentially grab from anywhere on the switch, no matter how it's balanced?
Usually, yes. At its highest point, it's a little difficult, but if we travel down a little bit more, then yes, we can.
Makes sense of that. So tell us a little bit, I know you want to cover your bumpers a little bit as well too. Tell us about what makes that special on your bot.
Yes, these bumpers are really cool if I do say so myself.
Yeah.
These bumpers make it really easy to switch from color to color because instead of having to screw them or having different other mechanisms, we have these called small latches. So if you open a latch, which this one is difficult, but if we come over here and we open a latch, you see it kind of unlocks, and this part that's connected to the bumper can be lifted up out of the robot over it, and then we can just switch it to another color. So instead of wasting time trying to change the bumpers and having other different sets of bumpers, we just unlatch and we lift it up and we switch colors.
Makes a lot of sense. That really cool to see. We know we don't cover bumpers a lot of times. I'm behind the bumpers, ironic, but love to hear what you guys are doing with that. Felipe is going to wrap us up here, talking about the drive. And if you don't mind as well, too, Felipe, I'd like to actually talk about. You guys have a lot of what looks like laser cut wood on your robot as well, too. Do you mind talking a little bit about that?
Sure. So our drivetrain, we just have we're running Swerve right now. We just bought some of the SDS Mark III modules. They've been working really well for us. They've been really reliable. As for all of our laser cut wood, the stuff inside the robot typically doesn't ever get hit or can take damage. So we figured it doesn't really need to be as sturdy or flexible, such as Lexan or sheet metal. It's also just really light, and the birch wood that we have cuts really nicely in the laser. It's really fast and it's easy for prototyping and building.
Yeah. Well, once again, this is Photon here that we're checking out. Thanks for taking the time to speak with us about your robot and your team and everything that's going on. Can't wait to see, of course, how you perform here at the Texas Cup and in future years as well as a team. Good luck the rest of the way. Thanks for taking the time.
Thank you.
We would like to thank our friends at Stryker for supporting this video. Stryker is looking for current and future FIRST alumni to join their internship program and FIRST mentors who are looking for a great career with a company who actually supports their FIRST journey. Go to careers.stryker.com to learn more. You can also directly support Fun by joining Fun Nation. Click the join button, and just for a few bucks a month, you'll unlock special perks and directly support us so we can keep making great content. Don't forget to like, subscribe, and ring the bell to stay up to date on our new videos. Keep the conversation going and provide your input to our content. Watch our live shows at twitch.tv/firstupdatesnow. Join our Discord at discord.gg/firstupdatesnow. And check out Fun FTC on Facebook, Instagram, and Twitter, and First Updates Now on Facebook, Instagram, TikTok, and Twitter.